So hey everyone, welcome to Spentarn learning platform, and today we are going to start a very refreshing course and a course which will help you to land in a VLSI sector job, right? In a core job that everyone wants to do. So the course name is Career in VLSI. We will be having this full course playlist on our YouTube channel, and we will be just doing this playlist within the upcoming 6 months, right? We will complete it. So this whole course will be like divided in categories. First of all, we will just learn the basics, Verilog, what is digital electronics that is required, which from which the questions is asked in the interviews, right? So let's start this course. So hey, I'm your instructor Puneet Vasist and the founder of Spentarn, Dr. Royd and Tuition Friend and many more others platform. So actually, I have initiated these platforms, and your help can boost up, and then I will be actual founder of them. And I am the ex-president of VLSI Club as well. So moving ahead, first of all, the first question comes is what is VLSI? And one more thing I want to tell you that these courses and these playlists would be having the videos, and the actual length of the videos would be minimum, right? So that you can grab maximum, right? Why minimum? I'm saying because the kind of confidence which we get is from only these short videos, right? The videos would be just less than 10 minutes. Okay. I will try to make them within 10 minutes, right? And would containing the material which would be like almost covered in 50 minutes in other videos, right? So first of all, what is VLSI? We need to know, and please don't mind the English. And let's start. So what is VLSI? As you can see, VLSI is the very large scale integration, right? This is the full form of it. So VLSI is something in which we have a IC technology and we can have many devices on a single chip, right? Generally, what we say to that chip is SOC. That chip is called as SOC. SOC is system on a chip, right? Here I'm saying many devices on a one chip. That means I would be discussing here SOC. If I'm talking about VLSI, just think that I am talking about SOC, right? We will be discussing about SOC here, how SOC work, how SOC is designed, right? We will be discussing everything in this playlist, right? But in this video, we are just discussing only about the introduction part of VLSI and SOC, right? Moving ahead, what is SOC? First of all, the first question comes up. SOC is related to VLSI, or we can say directly VLSI is SOC, right? Because what we are doing on SOC is similar to VLSI. Because in SOC, we just integrate the various kind of component on a single chip. This is the chip which you can see in your processor, maybe in the mobile processor, and maybe in your watches, smart watches, right? So this is the system on a chip. System, how we make the system? Let me take to that slide to you. Okay. For an example, if there is a kind of chip, this is my chip, right? What are the components we will be having on this chip? So the components would be our processor, right? Our digital signal processor, maybe processor and DSP is same, but I'm writing it here because the code or IP is something different. I will let you know what is IP. So processor is there, DSP is there. Again, networking devices would be there, networking kind of devices. What we say is Bluetooth, Wi-Fi modules, right? Everything would be on the chip. Apart from that, we would be having memory. Apart from that, we would be having RAM and some kind of GPU processors would also be there, right? So these all kind of component, not only these, but apart from them, we would be having other components too on this single chip, which is not more than like 1 or 2 centimeter. Okay, so these whole kind of component we are just integrating on the single chip. This is why we are saying it system on a chip, right? System on a chip. Everything just integrate on a single chip, then it would become the system on a chip, right? So this is what we say the VLSI technology, because VLSI is very large scale integration. We are integrating the different kind of various kind of component on a single chip, that is VLSI, or the chip is known as system on chip, right? Now let's again move to our slide where we were. Okay, this one. So system on a chip, right? We have discussed what is system on a chip. We have different kind of component on a single chip. It is known as system on a chip, right? So examples are smartwatch, complex systems, smart AC, smart washing machine. Where the smart word will come, that would contain the system on a chip or SOC, right? For an example, if you are wearing the smartwatch, you see the size of the smartwatch is very minimum, right? We cannot assume that this kind of thing would be happen in future. We haven't just assumed that, but right now it is in present. It is possible that we are wearing that particular smartwatch, or maybe in future we will be having a very small chip that we will just ejaculate in our blood or in our body, and that will only be sufficient to have all the data uh, around our surroundings, right? So the complex system, like, you just take an example of laptop, right? Nowadays what is going on, see, there's an example of HP. What HP is doing nowadays, they are taking IPs from different companies. Let me tell you what is IP. IP is our intellectual property, right? IPs are intellectual property. See, before 2010, right? Before 2010, what HP was doing is HP used to just take different component from different companies. Suppose there is a desktop of HP, right? This is the desktop. This is CPU we have, right? You know, the desktop was very much used at that time, right? Then this is the CPU, right? This is the CPU. This is our desktop, right? This is our keyboard. This is our mouse, right? Various components are there, right? So in CPU, what we have a motherboard, right? There we can see the different kind of ICs. ICs you can see black one, which is black one having the different kind of, legs, mainly 8 or 16, right? So that ICs we just embed or we just put on that board and have to solder them in hardware form, right? So this was doing actually in 2010 or actually in 2015, right? HP was doing that. They used to purchase that IC from Intel or from any other company. Different kind of ICs we use for different kind of functionalities. Suppose for an example, if I am using Wi-Fi in our CPU, so I have to purchase a IC for Wi-Fi, and then I have to embed that on that particular hardware, uh, that plate, right? This is the green color plate which we have, right? So this plate would be containing different kind of ICs for with different kind of functionalities. For an example, this IC would help us for networking. This IC would help us in this memory, or we can just ejaculate some kind of, or we can some add just some kind of RAM. We can add some kind of hardware devices, other hardware devices, right? So this would be a board which is like very huge, right? This is very much big and having different kind of ICs which we have for different kind of functionalities. So earlier HP was doing this one, right? Now what HP is doing in 2020 or 20s, after 2015, is they used to purchase the IPs from the companies like Intel, AMD, like Qualcomm, and the IP is the code, right? Code. The code would be in HDL format. Code would be in HDL format. HDL format may contain the Verilog or VHDL, right? So the code would be like HDL or VHDL. Sorry, HDL will contain Verilog and VHDL, right? These two languages we generally use in HDL, right? So VHDL is generally used in DRDO and the projects of defense, but generally 90% of the companies use Verilog, right? Verilog is very much popular, and this code would be written in Verilog, right? Or maybe in VHDL if we are just using in DRDO field or defense field, right? So this code will be purchased by HP from Intel, and then their engineers would make the SOC from it. Understand this thing? Maybe not. Okay, let me explain you again. Just erase this whole thing. right? So this is very much important part before you are entering in this field, because without this introduction to SOC, you will not know what actually is going on behind the scenes, right? Okay. So for an example, if I'm having the company like HP, right? I'm just purchasing the laptop. Okay, the laptop nowadays would be very smaller, maybe 14 inches with. Okay, and there you can see a kind of SOC in the processor, right? So what is SOC? SOC is basically system on a chip, where we will be having different kind of processor, different kind of networking devices embedded together, or just uh, would be put together on a single matlab chip, right? Single chip would be having, right? So what HP is doing nowadays for making this SOC, they used to purchase the IPs from different companies. Like IP means the intellectual property with, like, that would be a code, right? Encrypted code that everyone cannot use, right? So for an example, if they pay like $1,000 for one processor for Intel, right? Processor from Intel, uh, right? For an example, they want to make the 100 laptops. So what they will do, they will just 1000 multiply 100, they will just pay them this much of amount, and they will get 100 codes for 100 laptop for only the processor, right? Now not only processor is used in this laptop, they need to use networking devices as well. They need to use different kind of uh, you know different kind of other DSP as well, other processors as well. So they need to purchase that from other companies like Qualcomm and AMD. So they will purchase their IPs from them, from all of them, right? IPs from all of them. They will purchase IP from Qualcomm, they will purchase IP from AMD, they will purchase IP from Samsung, they will purchase from Intel, or maybe any other company, right? So what their engineers will do now, they will just take all the IPs together and will make this SOC, right? So what HP is doing, they are just collecting IPs from different kind of companies and just mixing them all together and making a SOC, which is system on a chip. Now they do not use any kind of hardware part or any kind of hardware ICs to put together on a huge board. Now they are taking only IPs from the companies and just putting all together, mixing all together the code and making the SOC. I have already told you what is SOC, where we will be having different kind of processor, different kind of networking devices on a single chip, right? So I hope this is clear to you. Now moving ahead. So this is the design flow, what we design in VLSI or to design the SOC. So basically we have different kind of fields. Okay. First one is front end and second one is back end, right? These are the two fields in VLSI where maybe if you want to become an VLSI engineer, we will be discussing front end as well as back end. Right now we are just focusing on front end, but I will let you know what is back end as well. So front end is something which comes front when we are making any SOC, right? There is a steps which we have to follow. First one is specification. What specification means is, for an example, if for take an example of Nokia. Before 2010, they were having the huge brand of their mobile in the market, and everyone was having that, right? But after 2015, what you can see is there is no Nokia mobile in the market. Why? Because they were unable to upgrade themselves according to the market demand, right? So this is why they got extinct from the market, right? So the specification comes there. The marketing team or the kind of specialized team would look into the market, what customer demands, and then according to that they will use to specify the kind of functionalities on the SOC, right? So specification comes there, where marketing team or specialist team would look after the market and then just take the overview what the customer demands, and after that they will specify that this kind of components we can use in our SOC so that the functionalities can be differ, right? Now next step is our architecture. What is architecture? Architecture is basically what where we just design the flow of SOC, right? So this is the second step and most important. The architecture engineers of VLSI having the high demand, huge demand, and having the highest salary in this field, right? Architecture. They used to design the architecture, what we are going to design and how we are going to design. After that, we have behavior model is something like, for an example, architecture is doing something like they are you are having a kind of empty plot where you want to make your house, and architecture will design that here we will be having bathroom, here we will be having the kitchen, here we will be having our another bedroom, right? So this work is basically from the architecture. Now behavioral model, what they will do is they will help us, like they will give us some kind of models where, as an example, for an example, you go to an contractor where the contractor will show you different kind of houses model, right? So behavioral model will do similarly like to that. They will just give you a kind of model which is similar to your design and you can use them, right? Now RTL coding. RTL coding is very much important. I've already told you RTL coding would be done with the help of HDL languages like VHDL and Verilog. So these languages would help us to design the SOC, right? Now comes to the verification part. Now after writing this code by the by the RTL engineers, we will move to the verification part, right? The verification is something that we have designed is right or wrong. If it is wrong, then we will move to again RTL coding part and we will just remove the bugs and then comes to verification again, right? After that, we comes to the synthesis part is something where we synthesize our code, and the synthesization means when we are just converting our code into netlist. What is netlist? Basically netlist is something in which we convert our this code into the gate level processing or gate level language, right? Gate level is something like where we use NAND, NOR and any other gates, right? So then we have gate level simulation. We check whether the gate synthesis is right, where the whether the net list is right or wrong. So here again we just verify that. So basically what we are seeing here is in VLSI we used to verify the different kind of components, different kind of steps again and again, right? Then DFT insertion, it is very much important, but I will let you know after the next slide, right? Now, backend, we comes to the backend. Now, floor planning. What is floor planning? Floor planning is something, for an example, if you are given the code, now floor planning, what they will do is they will decide on a chip where we have to place the components. For an example, if we just placing the processor here and we are just placing the memory here, and they will be having the huge distance now, and which can have the loss of time as well as our power, right? Then placement. The placement will be done only when this floor planning would be right. Okay. For example, if this is our processor and we are just putting all together the memory here, right? And this is the correct one, and then placement would be done after that. Placement, okay. Then clock tree synthesis. What clock tree synthesis is done? Why this is done? Because we need to just verify the timings here. So backend, what backend will do mainly? Backend will do the timing verification, and what front end will do? Front end will do the functional verification, right? So in the clock tree synthesis, what we will check? We will check the timing, whether they are taking the huge time or whether it is taking the very low time. So basically in VLSI, what we see is we want the low power devices, we want high speed, we want low the less area, right? These three things is very much important in VLSI field, right? So clock tree synthesis will do the timing analysis. Then again routing. What routing will do? Routing is something when we just connect all these components with the help of internal kind of wires. Not actually wires. It is done by using the metal kind of a layer, right? Then static timing analysis, again we check the timing whether it is right or wrong. Then physical layout is done. Physical layout is something where we just design its layout with different kind of tools like cadence, synopsis, right? then design rule check. Again, we check that design, and then we design the layout and schematic. And this layout and schematic would be just checked with the help of DFT insertion. Here we have taken some kind of pre-assumed insertion, and that we have insert in the design, and after that in layout and schematic, after layout and schematic, we will just check that again. If it is right, then we will move ahead. Otherwise, we will just again go to the code part, or again we will move to the part where it can be corrected, and then GDS to foundry. So basically, backend is the part where which we will be discussing in another playlist. But here in this playlist, we will be discussing about the front end only. So front end will contain these all kind of step. Okay, I hope you got it. And one more thing I want to tell you is here. Okay, system on a chip is basically working on the technology of ASIC. What is ASIC? Basically, ASIC is something which it is a kind of prototype, right? ASIC is a kind of prototype which we cannot change. Okay, and there is two type of prototype in our electronics, that is ASIC and FPGA. On in SOC, we generally use ASIC only. Okay, because it is a very complex system. SOC is a very complex system, so we cannot change it, so it will be considered in this category of ASIC, right? Application specific integrated circuit, right? This is a field programmable gate array, but here we will be using application specific integrated circuit, right? So ASIC we will be using in SOC. This question can be asked in the interviews. Please remember that ASIC is used in the ACC, SOC, right? So this is all about this video. Hope you got the idea of how SOC is designed, how the front end works in VLSI, right? So we will meet you in the next video. Please give it like I will be just targeting of the 10 likes on this video, and definitely we will be having the another video after that. So thank you for connecting with Spentarn. Thank you. And if you have any kind of doubt, you can just mail us on spentarn@gmail.com. Apart from that, we will be having our website of www.doctoroid.tech, and we are from basically Meerut, India. So thank you so much for joining us. I hope you got it. If you have any kind of doubt, you can mail me anytime, right? So thank you so much.